Okay, so let's look at a stress transformation. So we're starting out with this little element here uh, of a plane stress situation. So we've got in the x direction a negative 30 ksi, compressive, nothing in the y, and then for shear stress, we've also got again on the positive x face. It's going down in the negative y direction, so that'll be a negative 12 ksi, and then obviously for yx, same deal. So we got negative 30, negative 12, 0, negative 12, 0, 0, 0, 0, 0, everything else. So first step when we want to construct Mohr's circle is basically figure out where the center is going to be. That's our sigma x plus sigma y divided by 2. So negative 30 plus 0 divided by 2 gives us negative 15 ksi. Our radius, again, is just based upon the coordinates that we know. So I generally like to work off of just, work off the one face, work off the positive x face, but you could work off other faces if need be. But again, the coordinate that we know there is we got a negative 30 ksi and a 12 ksi for the x coordinate, and a 12 ksi for the negative 12 ksi for the y coordinate. So the radius there would just be based upon kind of the x and y distance, the x and y distances from the centroid that we previously calculated. So the x distance, is 30 minus the 15, and then that's squared, plus the y distance is just the 12 squared. So that gives us 19.21 ksi. So again, our negative 15 is the point, the center of the circle. We calculated the radius, so we can draw our circle. So again, this is the point we know on this face right here, on the positive x face. Based upon that, we can figure out what our principal stresses are. So our sigma 1 is just the center plus the radius, so minus 15 plus 19.25 gives us 4.21. Our sigma 2, that's the center minus our radius, so minus 15 minus 19.25 gives us minus 34.21. So those will be the magnitudes of our principal stresses. And then for the maximum shear, the situation for the maximum shear, that's going to be a cube that has a negative 15 ksi compression on all four faces. And then also on all four faces, we'll have 19.21 ksi of shear stress. But what orientation are we looking at here? So again, we know that we need to kind of rotate our orientation to get to the spot we're looking at. And the magnitude of the amount that we rotate needs to be half of the amount that we rotate on the circle. So if we're going from this point here that we know on this face right here, and we want to get to here, then we need to rotate by half this amount. So our 2 times our theta prime, that's just equal to the inverse tan of the 12 divided by the 15 to figure out what that angle is. So that gives us a theta prime of 19.32 degrees. So, and again, because we are going from this point to this point, we are rotating in the same direction as you're rotating on Mohr's circle. So we're going counterclockwise here. We're going counterclockwise here. And that's the reason why on Mohr's circle you have the negative shear stress increasing at the top and the positive shear stress increasing to the bottom. Otherwise, you'd have to like rotate in the opposite direction as what you do on Mohr's circle, which would be annoying. So anyways, basically so we know that essentially if we started out with negative 30 on and a bit of shear on this face, and then we tilt it up a little bit, we can basically this face here corresponds to this face here when we tilt it up. So when we tilt it up, when we rotate it counterclockwise a little bit, it's going to tilt up like that. And that means that the stress state on this face will have transformed from here to here. So it'll have changed from the minus 30 normal and the minus 12 shear to the the minus 30 and the minus 12 to the minus 34.21 KSI normal and no shear. So that's how we know that that's the one on this face, and obviously the other face is just given by what the situation is on the other end of the Mohr circle. So this one's a positive 4.21 KSI stress, tensile stress. So we also know that the state of maximum shear is always plus or minus 45 degrees from the location where our maximum principal stresses are. So if we want to do that, we can rotate, instead of rotating 19.32 degrees upwards, we can rotate 25.68 degrees clockwise. So if we start out with this, rotate it clockwise, we're going to end up with this situation down here. And again, the stress state there will be a compressive force of 15 KSI on all of the faces. So all four faces are getting that. And 19.21 KSI shear stress also on all four faces. And if you need to know the directionality of that shear stress, again, just kind of figure out what happened when you rotated. So we started out with a shear stress on the positive X face that was going downwards. So it started out as 12. So we started out here, and then when we rotate this way instead, that shear stress increases. So the shear stress on this face increases, and then when we rotate, this corresponds to this face here. So the directionality of this stress here is maintained. It's just increased. So the directionality starts out with there, and then obviously you can just fill in the rest of them based upon what you know about shear stress. So that's how you make sure you get your directionality right for the shear stresses that you're calculating using Mohr's circle. And yeah, that's it for that one.